Hello, everyone. Welcome back to my Code to Care video series. In this one, this is part 3 of discussing the topic about whether generative AI can automatically fix bugs reliably. This is an incredibly hard challenge. I talked in the prior videos about how difficult it is and why this data set was created. And a data set called SWE Bench, which is designed to help create an environment where people can develop generative AI and test themselves as to whether it can automatically fix bugs. So let me describe how you might test yourself. So let's say you built an AI system. And I just say AI system because it might be multiple large language models strung together in sort of an agent-based AI model. So picture an AI system, including generative AI there. And basically, the input that you get to your model is you get the code base that has the problem, the description of the problem, and then all the existing automated tests. And then your model has to predict a fix. Fix is just like a delta, basically a patch delta. So remove these lines of code, add these lines of code, edit this line of code, that kind of thing. So it's a predicted fix to this big code base. And then it's not the case that we compare the predicted fix with the real fix to make sure they fix it the same way, because you could fix it a different way. You could use different variables. It's a more difficult thing to evaluate, actually. So what these environments do is you take that predicted fix and then you run on it all the existing tests to make sure you didn't break anything, and all the new tests. New tests. So these two arrows. And then, if your fix passes all the tests, you didn't break anything, and it passes the new tests, then you have fixed the bug. That's the way the evaluation basically works. Okay? So basically, when this group wrote the first version of the paper, I'll go back here now. When this group set up this data set and set up the initial models, this was 1.5 years ago. So the models that existed 1.5 years ago, what they found is they could fix 1.96% of the bugs. Okay? Which is kind of their suspicion. They created this data set because they thought GenAI was easily solving, the medical exam, the bar exam, the CPA exam, all the tests we took to get into college and grad school and stuff like that. So they wanted to find a harder problem. And this is a harder problem. So the models at that time, which were able to pass these exams, could only fix 2% of these bugs. And I'm sure the easiest 2% of the bugs. So since they wrote that paper 18 months ago, they created an online site where people could post their own models and test them against this test harness to see what percent they could fix. Hey there, I'm just popping in to say that I'd love to hear your comments and feedback on this video. I read all the comments, so let me know what you think. Let me know what suggestions you have for my next video by putting in some comments below the line here. Thanks. And since that point, I looked today, the top scoring model, where is it, fixes 29.38% of the bugs. And I'm going to put an asterisk here. So first of all, this is a tremendous result if true, that basically 30% of bugs can be automatically fixed by GenAI and pass all the tests, and you can basically use it for updating your code base. The reason I put an asterisk here is because this is a public data set, and this is a public test. So you're building a student, so to speak, that's about to take a test, and you already know what the test looks like. So you can basically keep training your models on this public test set, and eventually the models are going to memorize aspects of it, memorize the patterns, that sort of thing. And so this number is probably inflated. It's probably higher than 2%, but it's probably not 30%. And so what's happened since is a Kaggle competition has been launched. Kaggle is a website where industry puts together AI competitions, basically, and then invites the community to sort of compete. So there's a new contest in Kaggle. It started in December, and the prize is $1 million. And most of these Kaggle competitions are like $50,000 prize or something like that. So it's a huge prize, but it's a huge benefit, actually, if we figure this out. And so what's happening is teams are basically building their models now. And what's going to happen is in March, the contest is going to be closed. You can't submit any more models. You can't submit any more code, that kind of thing. So March, everything is frozen. And then bugs reported between March and June in these repositories will be the evaluation set. So all the work is done before the new test set is created. Even the bugs are identified and fixed and that kind of thing. So they're going to build the test set after all the code is done and then run it in June. And so this will be a great opportunity to see what is the real performance of GenAI today on this particular task with a non-public data set, a data set that didn't even exist when the competition started or when you wrote your models. And the other nice thing about this competition is to win, you have to open source all your materials. So your code, your models, your approach, all that good stuff. So everything will be open sourced in June. We'll get a good feel for the performance of these models at automatically fixing bugs. And then we as an industry can take that learning and apply it to our own situation, whether it be different technology stacks or different situations, code bases, things like that. But it's a really exciting area, I think, from a use case point of view that has very high potential. And is really sort of beyond GenAI's capabilities so far, it seems. And so this is going to be an exciting year to see whether we as an industry can pull off this really important use case. So that's it. I hope that was interesting. And until next time, bye. Hey there, I hope you liked this video. I've added a next video at the end of this, so take a look at that if you enjoyed this. And if something resonated with you, please drop a comment at down below here. I read every comment myself, and I really appreciate hearing from you. Thanks.